Hello, Mr. Choose here with Bare Algebra. Make sure you like my videos, give them a thumbs up, subscribe to my YouTube channel, and share this to your friends so that I can help you understand algebra. In today's video, this is the second video I've done today on this subject. We're going to talk about solving quadratics by completing the squares when a equals 1. And remember, we're dealing with my ax squared plus bx plus c form of an equation, and it ended up being ay squared plus by plus c, where a has to equal 1. Well, this case, y squared minus 12y equaling negative 20 would be in this form. So now I have all the steps written down here from my earlier video. In black, it needs to be an x squared plus bx. This is y squared minus by, so that works. So 1 checks off. That worked. On number 2, we need to find b over 2, which equals 1/2 b, so I need to find b over 2. So step 1, we know that is a equals 1. So in step 2 now, I need to find b over 2, which b equals negative 12. So negative 12 over 2 would equal negative 6. All right. Now we're trying to find 3, which is b over 2 quantity squared, which is negative 6, squared, which is 36. And then 4, I'm going to add it to both sides. Add negative 6 squared to both sides. And then number 5, I rewrite and solve. All right, let's do all those steps now. I have what b over 2 is, and I have what b over 2 squared is. So now let's rewrite this. This becomes y squared minus 12y, and then we're going to add negative 6 squared to both sides. I've got my negative 20 plus negative 6 squared. So I just rewrote this. Now I'm going to take this part right here and factor it using this. So I am going to write it as y plus whatever b over 2 in parentheses squared is. So y plus, I take this number, square it, and then I got negative 20 plus negative 6 times negative 6 is 36. So I can rewrite this as y minus 6, because plus a negative 6 is y minus 6, and that equals negative 20 plus 36 is 16. Remember what step we took next? To undo a square, the inverse is a square root. So I take the square root of the left and the square root of right, but it has to be plus and minus that square root. Well, a square root of a square cancels out. So I have y minus 6 equals plus and minus 4. Remember what you do now? Use inverse operations to solve this equation. Add 6 to the left, add 6 to the right, and I have y equals 6 plus or minus 4. Well, that gives me 2 equations now. So I have y equals 6 plus 4, and I have y equals 6 minus 4. So in this particular equation, y equals 6 plus 4 is 10, and in this one, 6 minus 4 is 2. So I'm saying my solutions are, so the roots in this particular example are 10 and 2. Now what does that mean? That means that 10 will plug in and work in here, and 2 will. Let's see if they both will plug in and work. So if I put a 10 in here, I've got 10 squared minus 12 times 10 equals negative 20. And if that works, that means that's one root or spot on the graph of this quadratic where it crosses the x-axis. This is 100 minus 120. Does that equal negative 20? Negative 20 equals negative 20, which is true. Now let's plug in a 2. So I've got 2 squared minus 12 times 2. Does that equal negative 20? So 4 minus 24, does that equal negative 20? Negative 20 equals negative 20, which is true. Now, I will always have some students that will say, yeah, but how did you do this? Well, this was a shortcut that we wrote over here. You could always take your y minus 6 times your y minus 6 and use FOIL and find out that it equals y squared minus 12y plus 36. And it does. Y times y is y squared. I've got negative 6y plus negative 6y, which is negative 12y, and then negative 6 times negative 6 equals 36. So there was example 1. All right. So now that was problem 1C, and now we're going to do problem 2C. So all this has to come off, and we have to go through all of these steps to find the answer. All right. So on problem 2C, and at the end we'll have two problems 1 and 2 that you can try, that there will be a link to the problems. I've got x squared minus 4x plus 4 equals 16. All right. So now we do have this particular type of an equation, ax squared plus bx plus c. If I would subtract that 16 from both sides, it's going to look exactly like that. Remember, our first step is to find if it's got a 1 for a. Yep, it has a 1 for a. Yep. And then what's my b? My b is negative 4. So I can just write that over here now. B is negative 4. So I need to find 1/2 of b, which is b over 2, which equals negative 4 over 2, which is negative 2. That is step 2, to find b over 2, or 1/2 of b. Now step 3 is find b over 2 squared. So my b over 2 squared would be negative 2 squared, which is 4. Now, I go to step 4, which means I'm adding this negative 2 squared to both sides. First, I have to take and rewrite this, so I just have my x squared minus 4x by itself. I subtracted a 4 from both sides using the subtraction property of equality. All right, now I'm going to add this to both sides. So I have x squared minus 4x plus negative 2 squared equals 12 plus negative 2 squared. Now remember the shortcut here. It says I just break it into x plus, it's a perfect square trinomial, so this becomes x plus negative 2. We don't even need those parentheses. Squared equals 12 plus 4. I can rewrite this as x minus 2 quantity squared equals 16. Okay, do you remember what we do next? We take the square root of the left and the square root of the right, and it has to be the plus and minus of that. Well, a square root and a square cancel out, and I have x minus 2 equals plus or minus 4. So I add a 2 to the left, add a 2 to the right, and I have x equals 2 plus or minus 4. So if x equals 2 plus or minus 4, that's two equations. X equals 2 plus 4, and x equals 2 minus 4. So x equals 6, and x equals negative 2. What does that mean? Those are the 2 points on the x-axis where the graph of that quadratic will cross. So now you may say, yeah, but does it really equal 6 and negative 2? Well, what can I do here? I can take this equation we can take our original one, actually. We don't have to use that. Let's take our original equation and plug them both in. So I've got x squared minus 4x plus 4 equals 16. And plug in a 6 and a negative 2 and see what happens. So, if we plug a 6 in now, I've got 6 squared minus 4 times 6 plus 4, does that equal 16? So 36 minus 24 plus 4, does that equal 16? 36 minus 24 is 12. 12 plus 4 is 16. That worked. All right, now let's try negative 2. Negative 2 squared minus 4 times negative 2 plus 4, does that equal 16? Negative 2 squared is 4. Minus 4 times minus 2 is 8. Plus 4, does that equal 16? 4 plus 8 is 12, plus 4 is 16. It sure worked. If you want to check this, take x minus 2 times x minus 2 and make sure that it really equals x squared minus 4x plus 4. And it does. All right, so now I'm going to give you your 2 challenge problems. Those 2 challenge problems will be worked in the video of lesson 9.04B. So pause this and try to work them. Then when you start the video back up at the very top will be a link, if your device shows your links, that will take you to the video here. Otherwise, you'll have to find lesson 9.04B to find those. So here they are. Problem 1 is y squared plus 6y equals 16. And you can find 2 solutions to that. And problem 2 will be y squared minus 8y minus 1 equals 8. So you can find 2, and these have whole number solutions. So you can find both of these two values of y, plug them in, see that they work. Two values of y, plug them in, and see that they work. So make sure you like this video if it's helpful. Share it with your friends. Let them know Mr. Chu wants to help you with these hard algebra concepts. Subscribe to my channel. And remember, I'm Mr. Chu. My video curriculum is called Bare Algebra, and I want to help you understand these hard algebra concepts. Up here will be a link to the solution of these two problems. Down here will be the playlist of these types of videos. Up here will be an easy video to start introducing and explaining in a Math Minute video I had of completing the square. And down here will be another video or playlist. And remember, I'm Mr. Chu, and my videos will help you. I'll see you in another video.